In 1954, two brand-new jetliners ripped apart in mid-air, and the killer was something nobody suspected: their square windows. Both planes were de Havilland Comets, the first jet airliners in history, faster and higher than anything the world had ever boarded. And within 3 months of each other, both tore themselves to pieces in clear skies. Today we're cutting one open to find out why every airplane window you've ever looked through has round corners. The Comet flew where no airliner had flown before, nearly 8 miles up, far above the weather. But up there, the air is too thin to breathe. So the cabin is pressurized. The plane squeezes extra air inside, so passengers stay comfortable. That creates a pressure difference, pushing outward on every square inch of the hull. In effect, the fuselage becomes a balloon. And here's the part engineers underestimated: it inflates on every climb and deflates on every descent. Flight after flight after flight. To understand what went wrong, picture the stress in the metal skin like water flowing around obstacles. Where the skin is smooth and continuous, stress flows evenly. But a window is a hole. The flow has to squeeze around it. Around a smooth curve, it glides. At a sharp corner, it slams into a single point and piles up. At a square corner, stress can concentrate to roughly 3 times the normal level, sometimes more. And the metal at that corner isn't 3 times stronger. It's exactly as strong as everywhere else. That corner becomes the weakest point on the entire aircraft. Now, one flight doesn't tear a plane apart. 3 times the stress is still within what the metal can take once. But metal has a memory. Bend a paperclip once, nothing happens. Bend it back and forth 50 times, and it snaps in your fingers. That's metal fatigue. Every pressurization cycle flexed the Comet's skin, and at those sharp corners a microscopic crack grew a tiny bit longer with every single flight. Invisible, silent, until the crack reached a critical length, and the pressurized cabin burst like a balloon meeting a pin. Here's how investigators proved it, and it's one of the great detective stories in engineering. They took an entire Comet, sealed it inside a giant water tank, and pressurized it again and again, simulating flight after flight around the clock. After roughly 3,000 pressure cycles, the hull ripped open. The tear started exactly where the theory predicted, at the corner of a window cutout in the fuselage. The recovered wreckage from the crashes told the same story. Cracks born at sharp corners, grown one flight at a time. And the fix is the shape you see on every airliner today. Make the window round or oval, and there is no corner for stress to pile up at. The force glides smoothly around the curve, spread out instead of concentrated. No hot spot, no starting point for a crack. That's the whole secret. An airplane window is round for the same reason a balloon has no corners. It's not a style choice, and it's not aerodynamics. It's the shape that lets a cabin survive being inflated tens of thousands of times. Once you know this, you'll see it everywhere. Ship portholes, round. Submarine hatches, rounded. The corners of your phone screen, rounded, because cracks in glass love to start at sharp corners too. Even the windows on spacecraft follow the rule. Engineers call it designing out stress concentration, and it quietly shapes almost every object that has to survive pressure or repeated bending. The Comet crashes were a tragedy, and the lesson they taught is now built into nearly everything you touch. So, airplane windows are round because sharp corners concentrate stress, and repeated pressurization turns concentrated stress into growing cracks. Round corners let the force flow past. No weak point, no crack, no disaster. If you enjoyed this cutaway, subscribe to Cutaway. We keep cutting things open to show you how they really work.